Okay, so if you're into tech at all, you've heard the term AI model thrown around constantly, right? A new model just dropped, or this model was trained on that. But what does that actually mean? Let's break it down.
Now, I know it sounds super complex, but trust me, the main idea is way simpler than you'd think. And to make it all click, we're going to use one simple analogy that'll make it all make sense. So for a minute, let's just forget about all the complicated code and the jargon. I want you to picture an AI model as, well, as the end result of a secret recipe, like for a really, really smart cake. All right, first things first. What exactly is the model in this little analogy of ours? Is it the recipe? Or is it the finished dish you get to eat? This is probably the most important distinction we need to get straight right from the start.
A machine learning model, at its core, is a program that's already learned from a whole bunch of data. It's now ready to do something useful, like make a prediction. It is the finished dish, the cake itself, not the instructions. It's the thing you can actually serve and use.
Okay, let's really lock this idea in. The recipe, the actual step-by-step instructions for how to learn, in the AI world, that's called an algorithm. The model, well, that's the cake. It's the final delicious product you get at the end. One is the process, the other is the result.
All right, so if the model is the finished cake, then how do we actually bake it? Well, that brings us to the whole creation process, which you'll hear people call training.
Think of it like this. Baking an AI model really just has three main steps. Step 1, you've got to get your ingredients, and that's your data. Step 2, you need the recipe, the instructions, right? That's your algorithm. And step 3, you got to bake it and, do some taste testing. And that whole part is the training. And let me tell you, the single most important ingredient in any AI recipe is always, always the data. So if you want to make a model that can tell the difference between a cat and a dog, your ingredients aren't flour and eggs. Nope. There are thousands, maybe millions, of pictures, and every single one is labeled either cat or dog.
Okay, so what about the recipe, the algorithm? Well, it's not super specific. It doesn't say, look for pointy ears or check for whiskers. It's much more general. It basically just says, hey, computer, here are all the ingredients. Your job is to figure out for yourself what patterns make something a cat and what patterns make it a dog.
And this is the baking and taste testing part, what we call training. The computer just goes to work. It looks at a picture, it makes a guess, cat, and then it checks the label. If it's wrong, it tweaks its own internal logic just a little bit. And it does this over and over and over again, millions of times, getting just a tiny bit smarter with every single guess, until eventually it's a total pro at telling them apart. Okay, this leads us to another really, really important idea, and that's the difference between making the model and using the model. Let's stick with our food analogy. Think of it as the difference between being the chef in the kitchen and being the diner at the table. Training the model, that's the chef's job. It's slow, it's hard work, it takes tons of ingredients, our data, and a whole lot of heat from the oven, which is computer power. But using the model, that's the diner. You just show up, hand it a new picture it's never seen before, and boom, it gives you an answer, instantly. That's why building AI takes so much time and money, but using it feels so quick and easy. And here's the thing. You might not be the chef in this scenario, but you are absolutely the diner. You are using these models every single day. Let's run through a few examples that I guarantee you'll recognize. When your favorite streaming service recommends the perfect next show to watch, yep, that's a model. It's been trained on just millions of hours of what people watch to predict what you'll love next. Or how about that spam filter in your email that just magically keeps all the junk out? You guessed it, that's a model, trained to spot the patterns in spammy messages so you don't have to. And one more. When your map app tells you the fastest way to get home and somehow knows about that traffic jam up ahead, that is absolutely a model, trained on huge amounts of live traffic data to find the perfect route for you. So, let's recap. We've talked about what a model is, how it gets made, and where you're already using them. Now let's boil all of this down to the one key ingredient, the big takeaway. So, just remember these key bits from our recipe. An AI model is the finished dish, right? Not the instructions. It's baked using a process we call training, and training is all about learning patterns from ingredients. But none of it, and I mean none of it, can happen without that one single most important ingredient, which is data. That's it. That's the thing to remember. If you have no data, you have no ingredients. And if you have no ingredients, you can't bake a cake. It's that simple. An AI model is only ever as good as the data it learned from. And you know what? This actually brings us right back to the textbook definition of machine learning. A computer program learns from experience, that's just a fancy word for our data, our ingredients, and its performance gets better with experience. That's our whole baking and training process. See? It's just the technical way of talking about our recipe. So, now that you know the secret recipe, now that you know what to look for, what other models do you see out there in the world? Because I promise you, once you start looking, you'll realize these amazing finished dishes, these incredible models, they're being served up absolutely everywhere.